Im Modul 5 geht es das Thema Polarisation und optische Aktivität.
Module 5 is concerned with the topic polarization and optical activity, and there are several experiments using the polarizing filters contained in the case. In the last experiment of this module, we measure the optical activity of a sugar solution. The students should work out how far the polarization plane is rotated by introducing an optically active medium into the light beam. To do this, we need the laser from the case with a battery, the worksheet folded on the line like this to create an angle scale, which is later needed for the measurements, and both the polarizers from the case. In addition, we need an optically active medium in a glass container, such as a drinking glass or a beaker from the laboratory. The most important thing is that the container has straight sides. Lastly, we need sugar as the active medium and water, preferably hot, because this increases the solubility of sugar. The laser is positioned in such a way that the beam of light passes through the glass about 1.5 centimeters above its bottom and hits the angle scale in the half circle. Then the first polarizing filter is placed into the path of the light as a polarizer, in a vertical position with the short edge resting on the tabletop. The filter can be secured in place with adhesive tape. Now the second polarizing filter is placed directly in front of the angle scale as an analyzer, in such a way that the corner meets one of the 2 points marked with an arrow on the angle scale. By rotating the filter, you can reduce the spot of light's intensity on the screen. Keep tilting the polarizer until the spot of light disappears completely, and then measure the angle of the polarizer's bottom edge on the scale. In this case, it is 0 degrees, which is our reference measurement and should be entered into the table. Now we introduce the optically active medium into the light by filling the glass with water just high enough that the beam shines through the water. Then we dissolve as much sugar as possible in the water, that is, until the water is fully saturated. Now the experiment is repeated in the same way as the previous one. Adjust the light beam so it shines in the circle. And we are able to measure an angle of approximately 7 degrees when the light is extinguished completely. The angle of rotation is dependent on the concentration of sugar and the length of the light's path through the optically active medium, that is, on the diameter of the glass. Using this setup and this concentration as an example, we get an angle of 7 degrees. The objective of this experiment is to let the students think about what might happen if a different concentration of sugar were used. Hypotheses can easily be tested by experimenting with the amount of water. For example, by doubling the amount of water, which equates to halving the concentration. We simply measure the level of water, in this case 2.5 centimeters, and fill it up to around 5 centimeters. Then we can measure the angle again. Here we see that the light is extinguished completely at an angle of around 4 degrees, which is roughly half the angle measured previously.